Welcome. This video is on graphing rational functions. A rational function is basically a fraction. So here's a function in the form f of x equals p of x over q of x. We just have to say that the denominator q of x cannot be 0, and p of x and q of x are polynomials. Here's some various examples of rational functions. Notice that the denominator usually has an x. So when there's an x in the denominator, x squared, or x cubed, it's a rational function. It doesn't always have to be an x. It's just traditional that when we have an x in the denominator, we consider it a rational function. Let's look at some of these in detail, a little bit more detail. They're fractions, and one of the things we know about fractions is that the denominator cannot be 0. Right? We cannot have 0 in the denominator. It's called undefined when we divide by 0. Okay, so let's look at each one. Let's look at part A, or example A. It's not defined when x equals -5. Because if you plug in -5 for x, what's -5 plus 5? 0, right. And 2 over 0 is undefined. So we say that this fraction or this rational function is not defined when x equals -5. In part B, it's not defined when x equals 2 or -2. Because when you plug in 2, 2 squared is 4, 4 minus 4 is 0, and we cannot have 0 in the denominator. With part C, there's two numbers, 1/2 and 3. If you plug in either of those numbers, it would not be defined. Now, how do we get those numbers? Well, we have to factor it first, and then set each factor equal to 0, and solve, and that's how we get those two numbers. The last one, part D, there is no number that'll make it 0, because whenever you square a number and add 9 to it, there's no way to get 0 out of that. When you square a number, you're going to get a positive. So no way to get that fraction to be undefined. Okay, so that's our process, and we'll get into that a little bit more detailed. These values that make the denominator 0 were found by setting the denominator equal to 0 and solving the equation. Except in part D, there is no answer to that one, so that's why there's none. You try to solve it. X squared plus 9 equals 0. You could subtract 9 on both sides. So you get x squared equals -9. And then if you try using the square root property, you'll get a negative underneath the radical. Therefore, no solution. All right, we're going to talk about asymptotes. And what these asymptotes are kind of like guidelines. Okay, the asymptotes here are shown in red. They show a curve approaching it as it approaches infinity. So as you go to the right or to the left, or you get closer to a vertical asymptote going up or down, the graph, which is shown here in blue, gets closer and closer, but it usually doesn't touch. So notice the one on the left, the graph is in blue, and the asymptotes, which are in red. On the one on the left, there's two asymptotes, one vertical and one horizontal. And you can see it gets closer to the vertical asymptote going up, and going down, it gets closer to the vertical asymptote. And then going to the right, it gets closer on the right from the bottom, and it gets closer to the left on the top. The one on the right, there's two vertical asymptotes, and you can see the middle area, that middle section, it does cross the horizontal asymptote. And that's the only time it crosses, so it crosses through it. So anyways, these are some examples of the things we're going to be graphing. There's three types of asymptotes: vertical, horizontal, and oblique. Another word for oblique is slant. So if you're looking for other videos, you might just type in slant asymptotes or oblique asymptotes. One of the things is a graph will never intersect a vertical asymptote. However, it may intersect a horizontal or oblique asymptote. Vertical asymptotes. When graphing a rational function, values that cause the denominator to become undefined create a problem area and must be excluded. The graph of a rational function will approach these values that cause the denominator to be 0, but will never touch or cross those values. For this reason, we often draw a dotted or dashed vertical line at those locations. These lines are called vertical asymptotes. The procedure: set the denominator equal to 0 and solve. And the solution, if we get any, or solutions, are the vertical asymptotes. Basically just vertical lines. Okay, our first example. Find the vertical asymptotes, this one has 2, of the function f of x equals 3 over x squared minus 4. Do not graph. Okay, we're not going to graph yet. We'll get into the graphing in just a little bit. So what is the procedure? Set the denominator equal to 0. X squared minus 4 equals 0. And now we need to solve that. You have two options. You could either factor it, or you could use the square root property. Your choice. Okay, let's use the square root property. So I move the 4 over to the other side, so adding 4 to both sides gives us x squared equals 4. And then the square root property, well, we get rid of the square on one side. On the right side, we put the number underneath the radical, the square root. And then don't forget to put a plus and minus in front. And then the square root of 4 is 2. So we have two vertical asymptotes, x equals 2 and x equals negative 2. Those are two vertical lines. You find your x-axis, you go to negative 2 on the x-axis, and then you draw a dashed vertical line. And then you're going to go to positive 2 on the x-axis, and then again draw a dashed vertical line. Those are our vertical asymptotes. Okay, some more practice. Again, find the vertical asymptotes of the function. Do not graph. We will graph soon enough. So the procedure is set the denominator equal to 0. Now, you may notice that the numerator does factor also, but we don't care. Remember what the procedure is. The procedure is set the denominator equal to 0. That's what we care about for the vertical asymptotes. We don't care about the numerator. So we're going to set the denominator equal to 0. You have two options. You could either use the quadratic formula, or you could factor. I'm going to factor, but you can use the quadratic formula. So I'll multiply the first number and the last number. I'm using the grouping method. So that's negative 21. List our factors of negative 21. That's 1 and 21 and 3 and 7. Which pair will subtract to be 4? It's a minus 21, that's why we want the pair to subtract. Right, 3 and 7. And we want it to equal a negative 4, so the 7 must be negative and the 3 must be positive. So now we'll replace our middle term with those two terms, and then factor by grouping. So x squared plus 3x minus 7x minus 21. Factor an x from the first pair. So if we factor out an x from the first pair, we get x times x plus 3. And then the second pair, we could factor out a negative 7. Again, that'll give us x plus 3. So now we have x plus 3 times x minus 7. Set each factor equal to 0, and then solve each equation. So two answers, x equals negative 3 and x equals 7. Those are our two vertical asymptotes. Okay, again, more practice. You should pause the video and work these out on your own, and then come back for the solution. All right, first one, set the denominator equal to 0, add 5 to both sides, then divide by 7. So x equals 5 sevenths. That is our vertical asymptote. Okay, part B, set it equal to 0, multiply the first number and the last number. That gives us a negative 30. List our factors, list the pairs, 1 and 30, 2 and 15, 3 and 10, 5 and 6. It's a negative 30, so again we're looking for the pair that subtracts to be the middle number, not adds. If it was a positive 30, you would look for the pair that adds to be 13. But it's a negative 30, so we want the pair that subtracts to be 13. Therefore, we will use 2 and 15, not the 3 and 10. So if you use 3 and 10, it would be wrong. We want a negative 15 and a positive 2. See, that multiplies also to be negative 30. If you use the 3 and 10, they would both have to be negative, negative 3 and negative 10, to equal negative 13. But then when you multiply negative 3 and negative 10, you get a positive 30. And we need to get a negative 30 when you multiply. So therefore, the 2 and 15 is the pair to use. When you multiply positive 2 times negative 15, you get negative 30. And when you add 2 and negative 15, you get negative 13. Okay, replace the pair with the middle term. Okay, so we could factor out an x from the first pair. That gives us 3x plus 2. And then factor out a negative 5 from the second pair. The GCF is negative 5 because 5 goes into 15 and 10. And then the first term is negative, therefore it's a negative 5. That gives us 3x plus 2. It must match inside the parentheses. If it doesn't, there's a mistake. So 3x plus 2 times x minus 5, set them both equal to 0. And then solve each equation. So here are two vertical asymptotes. negative 2/3, and 5. Okay, now we're going to talk about horizontal asymptotes. Locating the horizontal asymptote is essential to graphing a rational function. Finding the horizontal asymptote is not as simple as finding a vertical asymptote. So when we found the vertical asymptote, all we needed to do was set the denominator equal to 0 and solve. This is a little bit different. So let's consider this general form of a rational function. I know it looks ugly, right? A sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus dot, dot, dot. I know, ugly. It's just a way of writing it. Try not to get confused by the notation. Okay, so the degrees of the numerator and denominator are in descending order. And the degree of the numerator in this case is n, and the degree of the denominator is m. Degree just means the highest exponent. Okay, and again, the denominator can't be 0. We'll just leave it at that. Okay, here's what we're going to do. This is our procedure. If the degree of the numerator is less than the degree of the denominator, that means if n is less than m, then the horizontal asymptote is simply y equals 0, which is the x-axis. So if the exponent on top is smaller than the exponent on the bottom, it's y equals 0. Now, if the degrees are the same, so if the exponent on top is equal to the exponent on the bottom, so if n equals m, then the horizontal asymptote is the line y equals a sub n over b sub m. Basically, it's the leading coefficients. So it's the coefficient of the exponent on top, the highest exponent, over the coefficient of the highest exponent on the bottom, assuming they're both the same exponent. And part 3 here is if n is greater than m. If the degree of the numerator is greater than the denominator, there is no horizontal asymptote. That'll be on the next video. That'll be for oblique asymptotes. Okay. I know it's a little bit confusing right there, but when we do an example, hopefully it makes more sense. So we have basically for horizontal asymptotes, 2 cases. If the exponent on top is smaller than the exponent on the bottom, it's y equals 0. If the exponent on top equals the exponent on the bottom, then it's a over b, where a and b are the leading coefficients. Okay, so just to make sure we know what we're talking about, the degree of a polynomial is the largest exponent. So in this case, the degree of this polynomial, 5x squared minus 2x plus 3, the degree of that polynomial is 2. It's the largest exponent. And the leading coefficient would be 5. It's the number that's in front of the x squared. Right? I know there's another negative 2 in front of the x, and there's a 3. But as far as the degree of the polynomial is 2, because it's the highest exponent, and the leading coefficient is 5. So just saying it again one more time, if the degree of the numerator, you might not have liked the notes on the previous slide. Maybe this one makes more sense. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is automatically y equals 0. If the degree of the numerator equals the degree of the denominator, then the horizontal asymptote is y equals a over b, where a and b are the leading coefficients of numerator and denominator. Yeah, that's better language, right? You know, that's always the thing about math, is you read it and you say, what? What are they talking about? All right, so let's find the horizontal asymptotes. Again, we're not graphing. We're getting ready to graph. We're getting closer. So let's look at part A. What is the horizontal asymptote? What is the degree of the numerator? Well, there is no exponent, right? There's no variable. So the degree of the numerator is 0. The degree of the denominator is 1 because there is an x. So therefore, the degree of the numerator is less than the degree of the denominator, so it's automatically y equals 0. If there's less x's on top, it's 0. If they're the same, it's leading coefficients. So how about part B? Same amount of x's, right? The degree on the top is 1. The degree on the bottom is 1. So this is where it's the same. So that's going to be the a over b. All right, so this one's going to be 1/4. 2 over 8 equals 1/4. So on the last one, the numerator was less than the denominator. This one, they're the same. The degrees are the same. How about part C? Same or less is the numerator. Well, the numerator is less. So it's going to be y equals 0 again. The degree of the numerator is less than the degree of the denominator. Okay, more practice. You might want to pause the video and work it out. We're just looking at horizontal asymptotes. We're not looking at vertical right now. So are the degrees the same or is the numerator less? They're the same, so it's going to be a over b. So in this case, it's 2 over 5. The next one, same or less? Oh, it's less. On the numerator, it's 1. The denominator, it's 2, so therefore it's y equals 2. The third one, same or less? Oh, it's greater, right? X squared on top. So there's no horizontal asymptote. Again, we haven't got to that one yet. That's going to be an oblique asymptote. Next video. Okay, some practice. Let's put it all together. Find all asymptotes. So we're finding the vertical asymptotes and the horizontal. We're not graphing. We'll get to it in just a little bit. So how about the vertical asymptote on part A? We set the denominator equal to 0 and solve. So we get x equals 3 over 2. That's our vertical asymptote. How about our horizontal asymptote? Well, the degree of the numerator is less than the degree of the denominator, so it's automatically y equals 0. All right, let's do part B. Let's do the vertical first, set the denominator equal to 0, and solve that. So our vertical is x equals 7. Now, how about our horizontal? Well, the degrees are the same. We have an x on top, x to the first power on top, and an x to the first power on the bottom. So now it's the leading coefficients. Well, the coefficient of the numerator, it's backwards. The coefficient of the x on top is -1, and the coefficient of the term on the bottom is 1 also. So it's -1 over 1. Therefore, the horizontal asymptote is y equals -1. All right, part C, again, set the denominator equal to 0. And then let's factor that. That factors to x plus 4 times x minus 6. I didn't show all the steps. Set them both equal to 0. So this one has two vertical asymptotes. X equals -4 and x equals 6. Now the horizontal asymptote, the degree of the numerator is 1. The degree of the denominator is 2. Therefore, it's y equals 0. Okay, so we're going to talk about a strategy for graphing a rational function. So finally, we're going to get to graphing. Again, so we have a rational function, p of x over q of x. We're going to find the vertical asymptotes. That's step 1. Finding the vertical asymptotes. And then 2, find the horizontal asymptotes, just like we've been talking about. And then here's step 3. Plot enough points to obtain an accurate description. How many is enough? Whatever you think enough is to get a decent graph. Might be just a couple, maybe about 4. And then draw it in. Try to show the function approaching the asymptotes. Okay, so a couple things. You could pick tons of points so you could get a really good graph. But we don't have all day, right? So we're just going to kind of, show that it gets closer without picking a ton of points. But if you, use a calculator to get points on a calculator, and then just show a few points to show like where it is and what it kind of looks like. Doesn't have to be perfect. If we want perfection, then we have you do it on a computer. All right, let's do this first graph. F of x equals 3 over x minus 4. So let's talk about the asymptotes first. What is the vertical asymptote? Set the denominator equal to 0 and solve, and we get x equals 4. So let's draw it. So go to 4 on your x-axis and try to draw a dashed line about right there. My graphics aren't that great. I mean, I try to change it up, but it's not perfect. So x equals 4. Try to use a red pencil if you can, or pen, to show the asymptote. Maybe get some colored pencils. I think it really helps out. Now the horizontal asymptote. The degree of the numerator is less than the degree of the denominator, so it's automatically y equals 0. So again, we'll draw a horizontal line, go to y equals 0, and draw a dashed line. That's right on top of the x-axis. Okay, now let's pick some points. So what points to choose for your table? Look at your vertical asymptotes. If there's, in this case, there's just one, but anytime you have a vertical asymptote, pick points on both sides of that vertical asymptote. So because this vertical asymptote is at 4, then pick points to the left of 4 and to the right of 4. However many you feel you want to do, hopefully you know how to use your calculator. Your calculator could give you all the points, so it's not like you have to work really hard at it. Unless your instructor doesn't let you use a calculator, then it's a lot of work. Okay. So let's pick some points to the left of 4 and to the right of 4. So how about to the left of 4, we pick 3 and 2 and 0. And then to the right of 4, we pick 5 and 6. Okay. Now, however you want to do that, if you want to plug it in one at a time or use your calculator, there's lots of videos on how to use your calculator to get a list of all the numbers, depending on your calculator. Anyway, so I'm going to put the answers here. So those are our results. Let's plot those points. And then we'll draw the graph. So there's those 5 points. That's good enough. That's good enough to show where the graph is. So it's going to get close to the asymptotes, but try not to touch it. Okay. Again, not great graphics, but hopefully it looks better than me just writing with my, with my hand on a piece of paper. All right, that's it. Let's do another one. 2 over x plus 1. What is our vertical asymptote? So if you set x plus 1 equals 0 and subtract 1 on both sides, you'll get x equals -1. Draw it in. There it is. What is our horizontal asymptote? Again, it's going to be y equals 0. There's no x on top and there's an x on the bottom, so it's y equals 0. So let's make a table and pick some points. Let's pick some points to the left and right of the vertical asymptote. So to the left of -1, how about -2 and -3? And then to the right of -1, how about 0 and 1? Use your calculator to get the y values. If you're not allowed to use a calculator, then you just have to plug in each one at a time and work it out. All right, so those are my points. I'm going to plot 4 of them. And again, very similar to the last graph, you can kind of see where it looks, where the shape is. Let's draw it in. There we go. Try not to intersect the asymptotes and show it getting closer to it, but not crossing it. All right, here's our next one. Vertical asymptotes. Well, we got to set the denominator equal to 0. Okay, so the denominator, it factors. It factors to x plus 3 times x minus 1. So if we set each of those equal to 0, we get 2 vertical asymptotes at -3 and 1. So there we have shown our 2 vertical asymptotes. How about our horizontal asymptote? Yeah, the degree of the numerator is less than the degree of the denominator, so it's going to be y equals 0. Now we need to pick points. So we're going to pick points on both sides of our vertical asymptotes. Now in this one, we have 2 vertical asymptotes. So there's kind of like 3 areas to our graph. There's going to be a part of it to the very left of it, a part of it to the right, and then a part of it in the middle between the 2 vertical asymptotes. To the left and right, pick 2 points. That's all you need. You need to know where is it to draw it in. Is it below the asymptote, below the horizontal asymptote, or above the horizontal asymptote? However, in the middle, let's pick 3 numbers, because there's two things that can happen in the middle. You could either get a U shape or kind of an S shape or a cubic function looking graph. So we don't know what it's going to look like. It has to do with the exponents of our original problem, but it's kind of hard to see that right now. So what we're going to do is always, when you have vertical asymptotes, more than one, pick at least 3 points between the vertical asymptotes. All right, so 3 points in the center, just to paraphrase, 3 points in the center region and 2 points on the outer regions. So here's my table. Remember, we have a vertical asymptote at -3. So to the right is -4 and -5. In the middle is -2, -1, and 0. And on the right is 2 and 3. Plug those into the calculator. I know it's kind of hard because like 0.4, 0.17. Well, 0.4 is like halfway up. 0.17 is just like a little bit up. Right? -0.67, like about 2/3, down 2/3, not a full unit. Anyways, I know it's hard with the decimals. Try to, be as careful as you can. So there's my points. So we could see to the very left, it's going to be above the x-axis. To the very right, again above the x-axis, and in the middle, looks like a U shape going down. So again, when I draw it in, I'm going to try to get close to the asymptotes. And there's our graph. All right, a couple more problems to do. All right, here I have a better grid. When you're making doing your homework, you could always go on the internet and find some graph paper and then copy and paste, into your paper. Make it look a little bit better. All right, so this one, vertical asymptotes. Let's set the denominator equal to 0. There's none. Right? X squared plus 1 equals 0. You can't factor that. If you put -1, if you add -1 to both sides, you get x squared equals -1. And then you use the square root property, you got a negative underneath the square root, so there's no real number. So this one has no vertical asymptotes. The horizontal asymptote is 3, because the degrees are the same. It's an x squared on top and an x squared on the bottom, so it's 3/1, which is 3. Okay, we could draw that one in. There it is. Okay, now what? What points to choose? We don't have any vertical asymptotes, so just pick points. Pick some points on, start with 0, and then both sides of 0. So, and however many you feel is enough to get a decent graph of what it looks like. It is symmetric. If you watch the video on symmetry, you'll know that it's symmetric across the y-axis. So if you draw one side, then you know the other side. But it's not a big deal. You could also just pick a bunch of points like 0, 1, 2, 3, and 4, and -1, -2, -3, -4. So always pick enough points. But if you do remember the symmetry test, if you replace x with -x and it comes out to be the same thing, then it's symmetric to the y-axis. It's also called an even function. There was 2 kinds of functions we discussed, even functions and odd functions. But again, just pick points. I only listed from 0 to 4 here. But you could also pick -1, -2, -3, -4. And you'll see that the other side looks almost the same, like the same. It looks exactly the same. So there's our graph. right, let's do another one. Last one, actually, for this video. And then there's another video for more rational functions. And we'll also talk about where it intersects the horizontal asymptote and oblique asymptotes. Kind of a teaser, right? All right, asymptotes. Set the denominator equal to 0. This is the square root property. So we got plus and minus 2. This is what I was talking about the last one. If you get a negative underneath that radical, then there's no solution. But this one we have a positive 4, so that gives us 2 vertical asymptotes. Negative 2 and 2. That means we're going to need 3 points in the middle and 2 on the outsides, right? Horizontal asymptote is y equals 0. The degree of the numerator is 1. The degree of the denominator is 2. So now let's pick some points. So here are my points. Negative 3 and negative 4 to the left. Positive 3, positive 4 to the right. And negative 1, 0, and 1 in the middle. Make sure you pause the video and you're able to get those on your own calculator. Okay, plot the points. And then when you draw it in, just try to show the shape getting closer to the asymptotes. And there's our graph. Kind of a cubic function in the middle, right? Okay, that's it. I'll see you here for the next video. Have a good day. Oh, sorry. Last little note. This one is symmetric to the origin. We're talking about even and odd functions. Just note that it's an odd function because if you plug in negative x or replace x with negative x, you get a negative f of x, which means it's an odd function, therefore symmetric with respect to the origin. So if you take any point on our graph, any point on it, and then take that point and then reflect it across the origin, you'll get another point on another part of the graph. Right. So just a little fact about this one. Again, you don't really have to think about, well, at least for me, it depends on your instructor. If your instructor wants you to see if it's even or odd, if that's one of the steps, then you do it. If they just say, you know what, just pick a bunch of points, that's good enough too. And show the asymptote. So it depends on your instructor, know what he or she wants. All right, I think that was the last of it. So I'll see you here for the next video. Have a good day.